So what about solving in weird ways? Again, if we understand the idea of using an inverse to solve an equation, we can solve even these weird equations with use a table. So here we have an f that we have no idea what f is or what it does, but we have the f function here as an input-output. Okay, so the f of x goes in this direction, but the inverse of f of x goes in the opposite direction. It goes from the y to the x. Okay, so this would represent the inverse of f of x. Okay, well, let's solve. And I'm going to solve using an inverse. So first of all, I'm going to inverse the log. Well, I'm going to get rid of that minus by using plus. So I'm going to add 3 to both sides. I'm going to get rid of log by undoing the log with an inverse or using the definition of log. Now at this point I'm a little bit stuck because I know that if I take the f of whatever that is, I get the answer 8. Well, I'm going to write it out like this. I kind of would like to know how to go from this input to that output. Well, I don't really know the calculation, but I do have the input and output. Okay, I have the output 8. There's my output. I want to go in this direction to get the input. Okay, so the inside function, which I'm going to highlight there, that's the inside part. That's my input, there's my output, there's my input, there's my output. But I'm just going to go in the reverse. So I know that my x minus 8 input must have been, in order to get 8 here, it had to start off as 4. So that x minus 8 must be equal to 4. Now I can solve the rest of this. So x is equal to plus minus square root 12. Okay, so again, this idea of, although I don't know what f is, if I understand this idea that input-output and going in this direction is an inverse or undoing the calculation, then I can see that if I end up with the answer 8, I must have started with the input of 4. Okay, so that means that this x squared minus 8 must be equal to 4. And that's the reasoning that I got to get that, to undo that step. So we're going to use very similar reasoning here. We're going to do the same thing. We're going to use the same f of x. So first of all, I'm going to undo the plus 2. To solve for x, I need to undo the plus 2. So I'm going to end up with minus 2 minus 2. So now my output is 4. Okay, so if I run some number through that function, I get an output of 4. Well, there's my output, and I want to go back to the input. I want to figure out what that input was to get the output of 4. Okay, well, that input must have been 2. So then I come up with this equation, 2 is equal to my sine squared x plus 1. And that comes from my table. Okay? To undo this f of x, I needed to use the table. My output is 4, my input was 2, so the 2 is equal to that x sine squared plus 1. Now I could do the rest of this. Subtract 1 from both sides. Okay, I need to undo the squared, so I'm going to end up with plus minus. Okay, and then to solve this equation, I can just use my circle. Okay, where is sine equal to positive 1 and negative 1? Well, the x must be equal to pi over 2 or 3 pi over 2. In fact, these are repetitive solutions, so I'm just going to combine this together as pi over 2 plus n pi, because every time I go halfway around, I hit another solution. Okay, whether I go forward or backwards, start at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. So there's my final solution. And again, I can solve, even though I don't know what f is, as long as I know how to undo it. Okay, and I have a table here that can undo it. Then I can solve it. Now, if I ended up with something like this, f of x equals 7, I can't undo that because I don't have an output of 7 to go back to the input. So that would not be possible. Okay, but for these ones, my output of 8, yeah, I had an output of 8 here that I can work out. Here I had an output of 4, yeah, I can undo that output of 4.